Okay. So, did we have any homework?
No.
Okay. So we're moving on to module 3, which is dynamics. Okay. So how many of y'all have heard of Newton's laws before?
Newton's law.
Yeah.
Newton's laws.
Yeah.
Yeah.
Okay. Have y'all worked with it before?
Newton's dead law.
What's Newton's law?
So you jump from first, second grade to third.
Every reaction there's an opposite.
Right. Okay, so for the purpose of this module, Newton's first law and Newton's third law will just be just theoretically. Okay? Newton's second law is going to be the one where they're going to analytically test you. Okay? So let's go through that.
So what are you getting tested? Saturday ones.
No, this is
The new section now.
moving on to syllabus. Okay, before I start with the revision, is everybody okay? Any questions before I move on? In terms of revision, in terms of Saturday.
Now we're not okay, but we are just accepting.
Yeah.
So we just focus on it.
Give me some more examples on the angular motion and all of those things. Just to cement that.
Now.
We got tomorrow.
We do have tomorrow, but see, Saturday is also important. But now today, because see, like now, I did revision. It's supposed to be working. Why? Which one you have to do? Is there any specific one?
No, just some.
Oh, what you having issues with each other?
I think just for us to remember the formulas and applying
You
them.
think, and you do some calculations and then get formulas from another way.
Yeah, I'm also bad. Okay.
That's confusing me now.
The power talk. You know, it's like when they have all the questions in.
That one you know we were talking yesterday.
Yeah.
That wasn't supposed to be part of that section. It's supposed to be dynamics. Because when I was looking at it again, the way they worked it out in terms of the work and power, that's dynamics formula. So just when we go through dynamics then.
Maybe can we before we go on, can we do a quick revision maybe on that work, like the last section, really angular acceleration?
I think I did give you a homework, but you're lying to me and telling me I didn't.
No, let me
For
see.
activity 2.3, didn't you have to do question 1 and 3?
Yes.
Didn't you have to do it at home?
Yes.
So doesn't that make it homework?
Wait, when you did that then?
What's the homework?
Yeah.
It was an exercise or something. It was wasn't all of it after that.
Then let's go back to the video and then just see the end of the video. Let's go back to the video.
I'm telling you.
I'm telling you I gave it to you as homework.
What you said?
Activity 2.3, question 1 and 3.
Oh no, we did that.
Activity 2.3, question 1 and 3.
Yes. What's that?
We didn't do it. You didn't do it for us, yeah.
Yeah, so that was homework.
That's homework.
Let's do it.
Okay. If I do that, will you be okay with it?
Yeah,
Will you be
yeah.
okay?
Yes, you did give us homework the other day.
Last week from
I'm not gonna go.
You wanna let us-
I gave you homework. Let's go to the homework. Right?
You let us do it first before you.
We didn't do the homework.
No, it was
Let's do it first before you does it.
It was homework on
Last week,
Last- yeah.
Friday. Last week, Friday.
last Friday. Yeah.
Okay.
Kind of cool.
I gave it to 1 and 3, yeah?
Yes.
Yeah,
Okay.
you said two is
The solution, yeah, that whole thing doesn't make sense. But anyway, 1 and 3, right? So, a load of 2000 newtons is lifted by a drum. So, what did they give you? Force, right? So, they're giving you the force is equal to 2000 newtons, right? Okay. If the diameter of the drum is 0.4 meters, calculate the torque exerted by the load on the axle of the drum. Now remember something, this would be your drum, right? It's being lifted, so your working force would be your what? The working line of the force would be this line here, right?
radius.
From the center, it will be your radius line. Okay? Okay. So your radius here is equal to,
0.2.
right?
Yeah. Yeah.
Okay, and then obviously it will exert some force. Okay, so the first one, they ask you to calculate the torque exerted by the load on the axle of the drum. Now, torque formula is equal to force times the perpendicular distance between the center point and the working line of the force, right? Which is, we established our radius. So this would be 2000 times 0.2, which is
400.
400 newtons.
Meters.
Fine, right?
Okay, 100.
Okay. B. Then they ask you to calculate the power if the drum rotates at 15 revolutions per minute. So they gave you this as 15 revolutions per minute. Okay? What's our power formula?
2 pi n torque. 2 pi times rotational frequency times torque.
Yeah, we could.
We did it Saturday.
Leave the next part.
Saturday we did it. Oh. Right. So this here
You have to convert it to
you
second.
convert it to revs per second. Okay? So 1 minute is equal to 60 seconds. So 15 over 60 is 0.25 revolutions per second. So this formula now will be 2 pi 0.25 400, which is
6 to 8.319.
6 to 8 points.
319.
9.
You need to learn round up properly.
Okay, trouble. Right. You're not doing this again today, yeah?
Fine, don't worry, it's right.
Okay. Everybody okay with this?
Yes.
Shame,
The
right?
next one is.
Okay. The next one, right?
Yeah.
Next one, they tell you that the tractive force on both sides of a drive belt. Now, what a drive belt would look like is you'd have this, and it's basically like, you might call a conveyor, right? It's the same thing.
Your bicycle.
Yeah. So you'll have something moving there,
Bicycle.
something moving there,
And,
right?
yeah.
So from here, yeah, this basically rotates and it will move this. I think you can even say this other way,
yeah.
it's like this way and
Correct,
that.
yeah.
But yeah, okay,
Yeah.
it's fine, right? Okay, so they tell you that the tractive force on both sides of a drive belt is 800 newtons and 500 newtons respectively. The diameter of the drive pulley is, so this here to there is 0.68 meters. It rotates at 300 revolutions per minute. Calculate the torque on both sides. Now, remember, torque is equal to your force times the perpendicular distance between the center point and the working line of the force. In this instance here, this would be the center, right? Your force is going to be generated from here. It's going to move there and it's going to basically move that line, right? So, what would be the R value? The working line of the force is going to be a radius, right? So your radius is 0.34 meters. So torque 1 is equal to force 1 times the working line. It will be the same for both in terms of the working line, right? So this will be 800 times 0.34, which is newtons per meter, right? And then torque 2 will be equal to F2 times R, which is equal to 500 times 0.34, which is 170 newtons per meter. Okay, so that's the torque on both sides. Torque 1, torque 2. Fine. Okay. Then they tell you they want the effective torque. Now what I told you the formula for effective torque is?
You
I
did
did.
That's the difference.
I did. Remember, yes, last week I told you, if you look at the summary page.
No, when you're telling people things on a Saturday, You didn't tell us.
No, I did tell you. If you go back and watch the recording,
T2
you will see. I
minus
told
T1
you on
left.
page 44. You will see
No, excuse me.
in belt drives effective tension is equal to T2 minus T1. And then I told you you will take the higher torque minus the lower torque, and you said, oh yes, it's going to become a positive value. That was the conversation last week, right?
I got you.
It will be equal to highest torque minus lower torque. So it will be T1 minus T2. Okay?
That was our
Right. So this here will be 272 minus 170, which is equal to 102 newtons per meter. And that's your answer. That's the effective torque. Is that fine?
Oh, see.
Right? Yeah. Good. Next one. Calculate the power transmitted by the separate forces. So, power formula is equal to 2 pi n torque. Right? We know our n because they gave you your n equal to 300 revolutions per minute. So we're going to convert this to revolutions per second. So 1 minute is equal to 60 seconds, which is equal to
5 for
revolutions per second. So power 1 will be equal to 2 pi n times torque 1. Right? Because the n will be constant for both. That thing is only rotating at 5 revolutions per second. So this will be 2 pi 5. Your first torque is 272, which is 133. Okay, this is in watts. Right? Then, or you could have wrote your answer as 8,545 kilowatts. That's also fine. Okay? Power 2 is equal to 2 pi n torque 2. So this is 2 pi 5 170, which is
534.
534. Fine? 5340.
Yeah.
Yeah, 5340.
5708 watts. Okay, that's our power for each force. Is everybody fine with it?
Yes.
Okay. Calculate the power transmitted by the driving pulley. So, how you can do this is the power transmitted is equal to the higher power minus the lower power. So, you say P1 minus P2. Or, you could have said the power transmitted is equal to 2 pi n and the effective torque. Okay? Either one of these formulas you could have used. This one here would be 8545.132 minus 5340.708. This is equal to 2 pi 5 times 102. So tell me an answer you get for both.
3204.44.
3204.424 watts with this one. Say 3204.424 watts. Everybody understand? Any issues? Okay then.
Yeah, done.
So I said, then you okay for Saturday?
Which one is coming out? Thanks.
No.
Oh.
I told you the main things you need to know for the work questions is torque is equal to force times
Can we do one example with the
converting
angle?
Okay.
Where you have the angle.
Okay. Can I take this on? Right? I'll take a picture of it before I take it on. Can I take it? Okay. Okay. So you have this is a nut, right? You have a spanner and you apply a force of 100 newtons. This distance is equal to 3 meters. Right? This is the information I gave to you. Okay? Then I tell you, calculate the force, calculate the torque exerted on the nut. How would you do that? Yeah. Torque. Okay. So torque is equal to F times R. So this would be 100 times the working line perpendicular to the force is 3 meters. So this would be 300 newtons per meter. Straightforward, right? Okay. Then I tell you that this line, this force is being applied, or the force exerted on the nut creates an angle of 30 degrees. Right? I never said the force being applied is applied at an angle of 30 degrees. I said that the force exerted on the nut is exerted at 30 degrees. Said that right?
No, you messed it up.
I think first time I said that right.
Yeah, first time you said that.
Second time I forgot what I said the first time. Okay. Okay, wait. The work done, or calculate the work done when the nut is turned through an angle of 30 degrees. It's not when the force is being applied at 30 degrees. If I said the force is being applied at 30 degrees, it means that this force is being applied at 30 degrees. Right? But that's not what I said. When to calculate the work done when the nut is turned through an angle of 30 degrees, meaning that this from this point here, it's basically turned
30 degrees.
This here is 30 degrees. So this D is still 3 meters. This force applied is still 100 newtons. You understand the difference?
Are we going to get on like definitely?
Maybe not.
That silence stuff, yes.
Okay, right? So the question is calculate the work. So how would you do that? Remember, for work, calculating work, when an arc is formed, you use the formula torque times angular displacement. Now this angular displacement is in what units?
In rads.
Right. We were given a angle. We need to convert that angle into radians. So we know that pi radians is equal to 180 degrees. So X amount of radians will be equal to 30 degrees. Okay? So you're gonna cross multiply. And you're gonna end up with that X equaling 30 pi all over 180. Do you understand how?
Yeah.
Anybody confused?
Whenever we see an angle, we just say 30 pi 1 divided by 180.
Take the angle, multiply by pi, divide the whole thing by 180. That's how you convert from an angle
Yeah.
to
Instead of using the calculator, just do it that way.
multiply by pi, divide by 180.
Clever for me. That's what we got.
Okay.
So 0.524.
Radians. So then our work, which is equal to torque times this, is equal to 300 times 0.524. That will be like 150 something.
157.2.
157.2 joules.
Sorry, man. The angle, that's angular displacement. So all you're doing is putting the angle in there.
For here.
Yeah.
Yeah.
But you're converting it to angular displacement, remember, using radians.
Yeah.
So you're converting it from degrees to fair.
So whatever angle they give us, times by pi divided by 180.
You got it in radians. Substitute it for this, multiply by torque.
I'm going to do it like that because every time you go to the calculator, do the switch and stuff like that.
Actually, use the calculator just to check if your
Check,
answer
yeah.
is right.
I usually did the one so
You do it with the calculator?
you said you're not going to use the calculator.
No, it's not about changing the
For
mode
radians.
into.
Yeah.
Okay, is everybody okay with this?
Yes.
Okay, this
Smart,
is
smart, yeah.
important.
Smart.
This is important for Saturday. Okay.
And see, Rowan said he's got a banger question. Right? You also got a banger question.
My banger question was like how question 2 was yesterday in kind of.
Okay.
Right? And the one with the resultant and
So you got one angle question, no one's got one. I think having all the Abby's questions
Is
is
there
better.
a direct-
I thought you have to.
Yeah, they all scheming together.
no, but you can't, because I would prefer if everybody gets 100%, but we need to see who's actually learning and applying the work. So we know after this test one, how to move forward. Yeah, like what we need to work on more, that sort of thing. Okay, are we cool on this?
Yes.
Everybody is, does anybody want to do anything else for tomorrow, I mean Saturday? Well, I'm gonna move on to Newton's laws. Nikki? Huh?
No.
Cindy?
Done, yeah, done.
Oh? Okay? Sure, huh?
So that this one here is saying that if you're saying that if the force is applied at an angle, that's when you find your vertical and your horizontal.
Just the vertical, in this instance.
Yeah.
Yeah.
Okay.
Okay?
But if
And let's say, like, if you look at page 39, right? Can you see how they tell you, and in the question they tell you a force of 400 newtons is applied to the end of the spanner, making an angle of 60 degrees with the spanner,
yeah.
right? That means, in that instance, this is 60 degrees, that's where your force is being applied, that's your working line, right? Then if you look at question B on that, the work done when the nut is turned through an angle of 70 degrees while the torque remains constant. So from here it was turned 70 degrees, right? Remember this 60 degrees is for the force being applied, and that's your working distance. So from here it basically moved till there, and when it moved like that it created an arc. Okay? That's what the question means. You understand what I'm saying?
I understand you, but I'm such a big question.
Yeah,
It's
because
okay.
your-
Me?
The force, the actual force, the
Biggest thing
moving
is
wheel,
you need to
you can still work on the
understand
force.
This one
What
was
they
Yeah.
can and what they are.
Yeah.
So you need to work on the
In the
actual-
first question of like how in A was when you calculated the torque,
Yeah.
when you were working on your force, you would have said whatever that force value was, sine 60,
Yeah.
and multiplied by R.
Okay, vertical.
You would have got your torque. They told you in the next question torque remains constant, and then you would have came to this formula. If torque remains constant, it's the same value as that.
So basically it's the same thing except for the fact that you're going to compensate for the 60 degree angle.
Yeah.
I
But
want-
that's only when
What
you,
about the actual force?
yeah, that's only related to the force. That's
Yeah.
all.
Yeah.
Okay.
Yeah.
Anything else, guys? For kinematics, angular displacement. I thought yesterday when we left, we were all okay.
You said this was
No, I.
You only got 10 minutes now.
What's it?
10 to.
No. I'm being it, obviously. Right.
No, he said he came to your time.
Then I must teach on Wednesdays.
But you're way ahead now. You sure you want to start a new section?
I'm not way ahead. Cause
Do not.
today I wanted to finish that first part of Newton's laws, right? Tomorrow I want to do work done and power for dynamics. Next week, Wednesday, I want to do potential and kinetic energy and be done with dynamics, right? Thursday, Friday, we were going to do statics. The following week, also statics and hydraulics. Then remember, not next week, not the following week, the following week, that weekend you're writing again. Because from tomorrow, not tomorrow, from Saturday,
1 month.
got like 3 weeks until you're writing again.
Okay, you got them there. You got 'em.
So, yeah.
Right, let's push this.
Now you think let's push after you. How much time for this? Okay, guys, everything here? Are you okay? Are you clear?
Yeah.
Fine. Right. Newton's laws is not bad. I just feel like one two things you may get like stuck on because well, you know the vertical and horizontal components slightly different here, but you get it. Okay, let's look at it. Then I'm looking at page 45. 45. Okay, so dynamics is the science of forces that cause motion. Remember what kinematics, what we said kinematics was?
Science that deals with motion.
motion without applied force,
Without
without
force.
worrying about applied force.
Without force.
Okay.
Just motion.
Kinematics is the science that deals with motion irrespective of the force that causes it. Right? Dynamics is the science of forces that cause motion. The difference between the two, right? Dynamics deals with the forces that cause motion. Kinematics doesn't deal with the forces that cause motion. Okay. So now the first time that you would have heard of Newton's laws, you worked with Newton's famous law F is equal to ma in N3. How many of you all know that law? F net is equal to mass times acceleration, or worked with it before at some point or something.
I think we
Yeah, David?
So everyone did,
Yeah.
everyone did physics in school?
yeah.
F
Yeah.
net is equal to m. Right? Newton's second
Yeah.
law. Yeah.
I
That's the one we're going to be working with.
remember MV1 and
Okay, so Sir Isaac Newton formulated his famous laws in 1686, Newton's first law. Newton's first law is also known as the law of inertia. You know what's inertia, everyone?
Yeah.
Right?
Yeah.
That's
No,
it.
shall I- shall I-
Okay, you know that if you're moving in a car, right? And if you turn your car to the right, your body tends to move towards the left. Because what that basically is, a body in motion will remain in motion unless acted upon by an unbalanced force. Right? So it's the same way, if you're driving straight and you press brakes, what happens to your body? Your body still moves forward because the force that was acting on it now acted away. Okay, so let's read on a bit. The property of an object to remain in a state of rest or uniform is called inertia. An object is inert because of its mass. The greater the mass, the greater the inertia. So when a man is traveling in a car, the car will slow down if the brakes is applied, but the man will tend to keep his forward motion because of inertia. Okay? So, for Newton's first law, an object, well, how I remember it was an object in motion will remain in motion unless acted upon by an unbalanced force. Okay? Yeah. Okay, well, the next page will tell you. Therefore, law 1 states that object keeps its position at rest or its uniform motion in a straight line unless external forces change the state. So if they ask you to state Newton's first law, that will be what you will say. Okay?
Which one?
See on the top of page 46, they tell you, therefore, law 1 states.
Oh, okay.
So everything from the word that to state, that's what you will say. Okay, Newton's second law. Newton's second law is defined as the change of momentum per time unit, which is proportional to the applied force and takes place in the direction of the working line of the force. So if they ask you to define Newton's second law, that's what you would say. Okay, and then they start to give you the breakdown of how they get to the formula. Okay, I'm not going to go through that part because they don't test you on that part. Where I want you to go to is, see to a little bit more down where they got number 1 becomes F is equal to ma. Right. Below that they say, note that F in formula 2 is the resultant force in the direction of the acceleration, for example in figure 3.1. Can you see that?
Yeah.
Okay. So, basically, if you have an object with a certain mass being accelerated in that direction, okay, there will be a force that's applied to this object to obviously accelerate it in that direction. Great? Right. Now, if a car is driving and a force is being applied to it, what would oppose it?
Yeah.
The air. But what would you call the air, the winds? Frictional forces, resistance forces. Okay? So that would act in the opposite direction of, so sometimes you'll see it as that, sometimes you'll see it written like that. Okay? These are your frictional forces or your resistance forces. Sometimes you see it like either, okay?
What's that? Is a U then?
It's called mu.
U, okay.
Mu. It's one of those things like alpha, beta, all those things. Like that. Right? Okay. So for Newton's laws, it's basically the sum of the forces that act on the object, which is equal to mass times acceleration. Okay? Now the sum of the forces that's acting on this object. How many forces are acting on this object? Two. It's going to be your force applied and your frictional force.
Actually, it's 3.
What's that?
Yeah, the weight of the.
But this is on horizontal plane, so
Okay.
you don't have to.
You didn't mention that, but it was good.
But when we're doing other examples, you see that. So your applied force will be in a positive direction. Your frictional force will be in a negative direction. So when you're writing on the sum of the forces, it's going to be your applied force minus your frictional force, which is equal to mass times acceleration. You're okay with it?
Now that's without.
Horizontal plane. Okay, just to give you an understanding or brief introduction to Newton's second law. You're going to see it more when we're doing examples, right? But so far we're okay with this.
Yeah.
Okay. Newton's third law. Newton's third law states that for every action there is an equal or opposite reaction. Okay? That's straightforward. Okay? Now, they tell you that the total force required, the motion of an object is influenced by gravitational forces, frictional forces, inertia, force applied to the object, and the inclination of the plane on which the object moves. That would be your total forces, the sum of your forces. Okay? It's everything that includes your gravitational forces, like you said, your frictional forces, inertia forces, the forces that's applied, and the inclination of a plane. Remember when a car is parked on a hill, you obviously have your handbrake holding it up, right? But if your handbrake wasn't holding it up, and the car is parked on the hill,
You put in gear down.
if you don't put it in gear to it, right? What's going to happen? It's going to roll. That's the inclination. Gravity will obviously act on it, but it will act on it at an incline. So the angle it acts on it, we're going to have to work that out. That was the one I was telling you about. You're going to see it next time. It's not bad, right? Next page. Important formula used to calculate motion when we ignore forces. Can I take this up? Yeah, I'll write some Bobby, right?
Sorry?
Okay, so when they say that important formula to use when we ignore forces, what they basically saying, we're not considering forces. It's for questions where you're not working with the forces when you're calculating your answers. Say like for displacement, initial velocity, final velocity, time, that sort of thing, right? They're saying that you can use these formulas here. So formulas you can use, what's that?
Same as the timing.
Yeah, it's very much similar. I think only here you don't have the gravity in it. It's like replaced with acceleration.
Force is Newton meters, huh? Yeah.
Force
Yeah.
is
that's
newtons.
Newtons.
Yeah,
So instead of the G, you have the A,
yeah, acceleration.
which is G.
G is gravitational acceleration,
So where would
but that's due to the force of gravity.
Gravity, yeah.
so it's also just plugging up. They're
Yeah.
using now.
So we'll get these formulas, isn't it?
Yeah, but just check the data sheet I gave you. Yeah, it's there.
Just remember, wherever there's a G, you replace with A.
Right? Okay,
Right?
so
Right,
yeah,
wherever there's a G,
it will be replaced with A. You'll see the formulas are very much like the only thing you may see is written out differently. Like in terms of the layout of the formula, they may have acceleration is equal to v minus u all over t, but it's the same thing as this formula here. They just made A the subject of the formula. Okay, okay. So that's the formulas that we have, right? Then they tell you that when we take the forces involved into account, the formula we use is F is equal to ma, where F is the resultant force or the effective force, and is also called the unbalanced force. So sometimes they may ask you, calculate the unbalanced force. All you do, you take F equal to ma. Done. Okay? Remember that, right? Right. A very important concept in this case is equilibrium. What is equilibrium?
that's now object is at rest.
How is
The
this?
force is the frictional force is equal to the norm of the force.
Yeah. So your applied forces is equal to your opposing forces. So what will happen to the object? It's not going to move. Okay? It's stationary. It's at rest. Right? So if you look at the diagram figure 3.2, you have something with a mass. You have a frictional force being applied in the opposite direction. You have an applied force in moving to the east. Okay? So they tell you that if M is stationary, your frictional force is equal to your applied force. Makes sense, right? We just said that now, that's equilibrium. If M moves at uniform velocity or acceleration, we apply Newton's second law. So your resultant force will be equal to F minus the frictional force, which is equal to mass times acceleration.
Explain that part there.
Okay, so, oh, that's it, right?
No.
So, okay, without the acceleration, right? So, firstly, I'm just using FU as my symbol, right? F mu, right? So, right. 73 says clearly. Okay, so what they're basically saying is that if M is stationary, meaning that if it's not moving, how will it not be moving? It will not be moving if M is. This object won't move because your applied force is equal to your frictional force. Right? Whatever is pushing it and whatever is pulling it is pulling it at the same force. Right? So it's not going to move it. Okay. Then they tell you that if M moves at uniform velocity or acceleration. So if you apply an acceleration but it's at a constant value or a velocity at a constant value. Okay? Then your resultant force will be equal to this. So it's basically the sum of the forces equal to mass times acceleration. Your applied force will be in a positive direction. Your frictional force will be in a negative direction. Mass times acceleration. That's how they got it from.
So if it's uniform acceleration, huh?
Oh yeah, or uniform acceleration or uniform velocity. Because remember, uniform velocity is going to give you a uniform acceleration because of these formulas, right? Okay? Hello?
Yeah.
Right? Okay. We're okay. Right? Then they tell you that if F is greater than the frictional force, where will the block move? It will move that way because your applied force is greater than the force that's opposing it. Okay? So, and if your frictional force is greater than your applied force, it won't move west. Right? It's opposing force, but it's not applying a direct force onto the object. Where, like, let's say if your car is parked, right? The wind is always blowing it. But is the wind moving your car?
No.
No. Okay? So, this will cause the object to be stationary. Right? So you see over there, they tell you there will be no movement, or it could be a situation where a braking force is applied. So in the case of when you're driving and you apply your brakes, the frictional forces will obviously act, and then your force applied is moving in the other direction. Okay. Okay. So this would be okay. So that was your introduction into Newton's first law, second law, and third law. Does anybody have any questions before I start with examples?
No.
Fine. Sure.
It's easier this time.
Yeah, true, it is. It's so clear. Still clear, not clear.
It is.
It is clear. Okay. Thank you, Fred.
Yes.
Okay. You want to take it down?
I'm
Still,
I'm
it's
taking down.
confused me. If the friction force is greater than the force in the direction it's going, how can it be stationary?
See,
Because friction
a
force is
frictional
not
force
applied.
is not a force that's actually being physically applied to something. Right? Like,
Oh yeah,
for
yeah.
example,
The ground is friction.
Yes.
So okay.
right, but it's not actually, it's just used to slow down something. It's not applying a force to push it in the opposite direction.
The thing is, to overcome that resistance,
You need a
you need to
applied force.
overcome. You need to overcome
A
that
frictional
resistance.
force.
Yeah.
Exactly.
Yeah.
That is literally it. So we all have an understanding of that.
Yeah.
This section is not bad.
So the frictional force will always be the wind.
Not always the wind.
No.
It's dependent on, I just use wind as an example, right? You could even use like the road, like how Viral said as an example. Like a speed up. That would create, because what happens is it alters the motion or the speed at which you have to move. When you hit a speed arm, after you hit the speed arm, you if you're coming up and you're slowing down, or if you hit it at a fast speed, you're either going to slow down or you're going to go very fast over it. Right? All those stuff are frictional force. Somebody pushing against something, that's going to be a frictional force. So if something is in the way, all those sort of things.
Yeah, even like your car, if you're pushing the car or driving the car, if you put the accelerator, the engine stops pushing it, eventually it will slow down because the
Frictional
frictional
force
force
is also
is slowing it down.
Okay, because can I take it up? Can we start with the examples?
Yeah.
Okay. Nice. So let's look at example 3.1. Okay, so example 3.1, they tell you that an object of mass 2 kgs is accelerated on a horizontal plane at 2 meters per second. So the acceleration is equal to 2 meters per second squared by a force of 40 newtons. Okay, calculate the frictional force. Right? Now looking at this diagram, what is missing from the diagram?
Frictional.
Frictional force. Which direction would frictional force act?
Opposite.
Opposite, right? So from here, this here is, you just say mu r, right? Here, frictional force. Okay? Right. So far we are clear on what's going on here?
Yeah.
Okay. They want to know how to calculate this. So Newton's second law is the sum of your frictional forces is equal to mass times acceleration. The sum of the forces. How many forces are acting on this? Two. Yes, it is. Your two forces are F and frictional forces. So F is moving obviously in the positive direction. Because in this instance here, I would say that whenever you have an applied force, take that applied force as your positive direction and everything else as your negative direction. Okay? So our applied force is being applied to the right, so we took right as positive. So everything to the left would be negative. What's moving to the left? The frictional forces. Right? So it will be minus that equal to ma. We know this. We want to work on this. We know this. We know this. Right? So 40 minus frictional forces is equal to 2 times 2. So this would be 40 minus this equal to 4 minus this is equal to minus 36. This is equal to okay. Oh yeah. Anybody having an issue with this?
The friction is high on the block, yeah?
Hopefully you'll work something.
Okay, we okay with this? So you know another thing I've got to tell you. See on page 46, just above Newton's third law, below the diagram figure 3.1. Right? They say that when an object is applied or is moving only under the influence of gravity, then your force will be equal to mass times gravity.
46.
Because remember, F is equal to ma. Right? If the object is free falling, what is it accelerating by? The gravitational
That becomes the
acceleration. That is it. Okay. So now let's look at example 3.2. So for example 3.2, they tell you that calculate the tension in a cable supporting a lift. So you have, just say this is your lift, you have a cable with a mass of 600 kgs. When the lift is accelerated, and the first one they tell you upwards at 0.2 meters per second squared. So I'm going to take up as positive, down as negative. Okay, so that's the information they gave us. What else can you tell me about this?
What is the force acting down?
What's going to be acting down? Gravity, right? So we can safely say that the force of gravity acting down will be your mass times the gravitational constant. Yes? Cool? Okay. This value here is equal to 600 times 9.81. Now I know you're going to ask me why I never said negative 9.81. Because remember.
No, we're going to ask you how come you don't have 9.8 instead of 9.81.
Oh, because I changed the basis. Right. Why I didn't do that was because when we're doing these questions here, you see how when we're writing out our formula, we include the negative side for whatever's moving in the negative direction. So if you go and put a negative and a negative again, it's going to make it a positive. Okay? So, exactly like how I got it written here, mass times gravity, write it as mass times gravity. Is that okay?
Yeah.
You'll see, you're going to see it now, right? After that, if you don't like it, then we can see what we can do about it, right? So, 600 times 9.81?
5886.
On the dot?
Yeah.
Newtons, right? That's our, what's the answer to it? The tension, right? So basically they want to know the force moving upwards.
Oh, is that?
That's what they want. Okay?
So which, sorry, I know you want to do the whole thing, but what's acting down? Is that now your frictional? Friction?
Gravity in this instance is your frictional forces. Okay? Remember we said in the other one when we talk about the total force required, we said gravitational forces,
Yeah.
frictional forces, inertia of the object, the applied force, and the inclination of the plane. So in this instance here, it's gravitational forces and it will act downwards.
Question. The mg, right? What is that?
So remember how we have, remember how we have force is equal to mass times acceleration. Okay? If an object, if gravity, just pretend you have a ball and this ball is free falling. So you took the ball and you dropped it. Right? You never threw it at any initial velocity. There's no applied force from you. What's the only thing that's acting on it? Gravity.
Yeah.
So remember this G that we speak about is gravitational acceleration.
Yeah.
So this becomes mass times gravity.
I get that. So mass, right? That's the not the weight. So is mass and weight two different things? Or
In general,
Yes.
mass and weight is two different things,
two
right?
different things.
But this is the mass of the lift, the
actual-
elevator, right? Okay, so this elevator is dangling somewhere in the air.
Yeah.
So it's basically in the air. Obviously, there's going to be gravitational because remember, if this cable wasn't here, what's going to happen to the lift? It's just going to fall. And why would it fall? Because of gravity. And the force of gravity that's pushing this down is 5,886 newtons. Okay? This cable is holding it up.
No, I get that. I was just wondering if the kilo, the 600,
Yeah.
whether that would have taken into account gravity already or not.
No. It's
What's that?
just the weight of it. If you put that whole lift on a scale,
Okay.
it will tell you.
But the 600 is gravity.
Yeah, but no, okay. So they want to know F. Okay?
Yeah.
Remember Newton's second law, the sum of your forces is equal to mass times acceleration. Yes? Yes. Okay, we took up as positive, down as negative. So the tension force will be a positive value minus mass times gravity because that's acting in the opposite direction. You can see where I introduced my minus sign? Okay, so whatever's acting in the positive direction, I wrote it as a positive value. Whatever's acting in the negative, I wrote it in a negative value.
But the whole thing is the frictional force for the tension going up, right?
Which whole thing?
The mass times the gravity, the 500.
That's your, yeah.
That's your frictional.
The mg
No.
is the frictional
But
force. The
see,
is the
frictional
force.
force, you'll call it, your wind, your bumps in the road.
No, I
whatever.
understand. I'm saying like,
But it is acting away from what the force
The
applied.
opposite of the actual.
Yeah. it's gravitational force in this instance, right? But you can see the next one, because it's moving downwards. Okay, you'll see this, right? Okay. So this is that MA. So the tension force minus 5,886 is equal to 600, and is being accelerated at 0.2. So F is equal to 600 times 0.2 plus 5,886, and then this F is equal to
6,006.
Everybody understand how I got to the answer?
You skipped some steps, but
Which steps?
no, but
No, what?
it
Yes.
people wanted it this way.
No,
No, moving the things across.
Oh, the maths part.
Yeah.
Oh, I thought you were talking about the science part.
No.
Okay, but guys, you understand the concept of what was happening in that question?
Yeah.
Bilal, you understand? Fine. Okay, let's look at B. B, they tell you that now it's being accelerated downwards. Okay? So now this elevator is moving downwards. So remember, the tension from the cable will now become your what?
Your frictional.
Your frictional force. Okay? So if this is now your lift and it's moving downwards, right? Okay? So this mass times gravity is now in a positive direction. Okay? So this is positive, that's negative. That tension force is now acting in the opposite direction, because this diagram is now moving, not diagram, this lift is now moving downwards. Okay? It's accelerating at 0.3 meters second squared. Okay. Do we understand what's
Will it not be the other way around?
Right.
Because I'm just saying the force now is downwards,
Mhm.
and the pulling of this cable is upwards.
Mhm.
It would be.
So if not get the force from mg.
Yeah, but see, in this instance, right, the force that's opposing the motion is going to be the tension in the cable. Okay, so let's just call this
So the lift will
FT.
be 50.
Can we label
And then the
that
cable will be dropping its
that the frictional?
It's gravitational force, so we just leave it as gravitational. Because you're going to see questions where you're going to have frictional force and you're going to have gravitational force. So if you call it one label, you're going to mix it.
So the question is, is it full or empty?
Are you okay? Good. Okay?
So, but I'm also on the same page as Nikki too, so I feel it should be the other.
Nice, yes. But then,
Because you're saying, the force going down.
I'm calling
is
this now
acceleration.
the tension force.
So can't you just make it T going up? That's the
You
tension.
can't just start labeling your own thing.
Why?
No, it don't work like that. Right? This is the quiz, banana. Right?
So the gravity force, no matter what, is always going to be.
It's going to
down.
be acting downwards.
It's always going to be
Yeah.
down. Whether this thing's moving up or down. Like it's going down now, but they're both.
Okay, so in this instant, okay, so the sum of the forces that act on it is equal to the mass times whatever the mass is accelerating by. Now, the acceleration force or power would come from probably a motor. Okay? Okay. You understand that part, right? That's how it's moving. And then the other forces that act in it is this cable is either pulling up this elevator or it's releasing it, like how you said, right? Gravity is always pulling this thing down. So if it's moving downwards, it's moving with gravity.
Yeah.
If it's moving upwards, it's moving against gravity. So in this instance here, what force would you like first?
mg.
But would it be a positive or a negative? Positive. It's moving downwards.
That's the, yeah, it's
There.
going
So mg, and then what would you write after that?
Minus FT.
Minus F of the tension force. Why? Because now your tension force is pulling it up while it's moving down. So this would be minus F T is equal to mass times acceleration.
This is like vectors. I can see that getting a diagram right.
But it's not as bad as that. I promise you, you'll see that. Eh? Okay, so this is 5886 minus Ft equal to 600 times 0.3. So Ft is now equal to what's it equal to?
5706.
You're reading from the answer now.
Yeah.
57706.
Yeah.
100.
Yeah.
Everybody understand what? Yeah. Which part?
I'm confused.
On which part? From the maths?
Yeah, this you see this is a second sum now. It's
This one.
yeah. You see.
All I did was I took the FT, that's it, because it's negative, and I took this,
Yeah,
this side because
You
it's
also changed the positive and negative up and down. You swept them around.
Yeah.
Yeah, because you need to explain that. Why.
Now I did explain that. I said when the direction in which it's moving, you will take that as positive, and the direction it's opposing, you take that as negative. In this instance, the elevator is moving downwards, so I took down as positive.
When we're moving up on the top,
We
the
took up
force,
as
force
positive.
was, the lift is going up now. Now it's going down. There's your signs on the top here, plus minus
There's it there,
directional
but then
change.
here
Yeah.
it's the opposite way.
Why it's opposites?
Okay.
Because the direction in which it's moving. Right? This is the elevator. Right? See on the question where it says A, it moves upwards.
Yeah.
Right? So I took up as positive. The next question, this elevator is now moving downwards. So I took the direction in which it's moving as positive. Like how in this one here, the force is being applied to the right. Okay, so I took the right as positive. So of all the forces that's opposing it would be to the left, which is negative.
Oh.
Okay. So wherever it's moving, wherever the force is being applied, whatever it's moving towards, whatever is pushing it in that direction, positive. Whatever's opposing it or pulling it or whatever opposite words of the first words I used, that's negative. I forgot, I said 3 words, I remember 2, I think that was the answer. Right? Are we okay with it?
Yeah.
Yes, everyone?
Yeah.
Okay. Now I'm doing a time before Avi come and ask me out. Guys, you took a lot of my time.
Hey, just hold on. Kemplan ops, we do revision.
You head down.
It's questions that grinders.
That's the problem, we get crushed here.
Okay, let me do this one because it's
Okay,
the
that's
last,
fine,
right?
that's joking.
This is one more and then I'll.
Reversal income.
Yeah, like how I come knock on the door and then he carry on. If I don't come, he won't.
Yeah.
Right. So, calculate the magnitude of the force required to. Okay, let me draw the diagram that you gave me, right? So you have a 15 kg block,
Yeah.
right? This 15 kg block is basically holding up this 10 kg block.
Yeah.
Okay?
Yeah.
Got like a pulley thing there. It's holding this up, right? So, calculate the magnitude of the force required to accelerate the 10 kg mass uniformly upwards at 0.8 meters per second. Now, what did they basically ask you for? Is basically if you pull this 15 kgs, right? What force do you need to pull this 15 kgs by to cause this 10 kg mass to move up at an acceleration of 0.8? Does everybody understand what I'm saying? Okay, so so the force being applied will be applied in that direction. Agreed?
Yes.
Okay. The frictional force acting on the 15 kg mass is 25 newtons. So your applied force is being that way. Which way would be your frictional force? The opposite way. Right? So this here is equal to 25 newtons. Fair. Right? This block is basically dangling in the air.
Source got force.
So what's going to act on it?
Gravity.
Gravity. So this force will act down, mass times gravity. Okay. So far we're all on the same page. Cool. Right. So in terms of my directions, pay attention to me, right? In terms of left and right, okay, is anything acting on this horizontally? No. Here, your applied force is in what direction? West to the left, right? So whatever is moving this object is to the left. So what am I taking my positive as?
Left.
Right? So this here is to the left, that's going to be to the negative to the right. Okay? In terms of up and down, when you're pulling this block to the left, where is this block moving?
Up.
Up. So the applied force on this would be up. So up as positive, down as negative. Clear? Okay. What was the question? No, wrong example. Calculate the magnitude of the force F required. So they want to know that. They want to know the F. How would we do that?
Well, they also gave you 8
Okay,
meters.
so you say F.
Needs to first look at the force being applied by the same kilogram.
So,
Which should be just mg.
mg.
yeah.
Right? So the mass being applied by this is,
That's
which is 98.1 newtons. Right?
Right.
So we know this force here. We know this. We know. Oh wait, I forgot the acceleration.
Yeah.
Acceleration is
0.8.
So the 98.1 we can write on top.
the
Behind, well, next to the. That's the opposite. So,
yeah, it's here, it's
So
here.
it's
All this
basically-
here is basically this.
so basically on top it's the resistance.
Yeah, it's moving in the same direction as
Yeah.
that. You don't understand what it says.
Resistance.
Because the string is transferring the force.
Right.
Oh.
So basically, remember what's pulling this down? The same mg is acting here. It's acting here. It's acting there. You all see that, right?
Yeah.
Okay. So now we know what we have. We know what we want. Let's calculate it. Okay. So Newton's second law states that the sum of the forces acting on the object is equal to the mass times the acceleration. Right? Okay. Remember something, right? When this force is being applied, this object and this object are going to accelerate at the same constant acceleration. Okay? So for this end here, this here would be equal. Okay, before I come to that part, right? Your sum of your forces is what? How many forces are acting
That
on
will be
this?
your
Three
three
forces.
forces.
Right? What's your three forces?
So your frictional force, your resultant force, and then the force by the weight of the
Right.
kg.
So your applied force, frictional force, gravitational force. See, I told you don't call this one frictional force,
I get
right?
it now, yeah.
So your applied force is going to be a positive force.
Yeah.
Why? Because we took left as positive, it's moving to the left, right? Your frictional force is going to be a negative force. So that's that.
Minus.
Gravitational force, which is equal to mass times acceleration. So the sum of the forces, these are your three forces, that's equal to the sum of the forces. Right?
Yeah.
Yes.
Am I fine? Okay. We want to work on this. This is F minus. The value of U is 25. The value of mg is 98.1. Your mass, right? What is your mass? 25. It's going to be 10 plus 15. Okay? And remember on this end, it's the acceleration of
Both.
the masses on the system. Okay? So, 15 plus 10, and they accelerate at 0.8. Guys, are we all okay with what I'm doing now?
Yeah.
Anybody confused? Fine. So this will come to F minus 123.1 equal to 25 times 0.8.
26.
20.
20.
Yeah.
Say F is equal to 143.1. Anybody confused about what I did here?
If, just say hypothetically speaking, they're 10 kg, right? And I think let's say it was in an angle like this, right? Would you have to now go into work out your horizontal and vertical?
Yeah.
But
Okay.
they'll
No,
never,
it's
they'll
thinking
never
now.
ask you one like that. How they'll tell you is, they'll tell you that a car is on the incline.
Sorry, man, because we know you never give us simple ones.
No, this is now, right? And the car is moving upwards.
Right.
Remember, gravity will act on it.
So
Like
you have
this.
to work out the force of gravity.
This is your block.
I have to work
The
out the
forces we concern.
angle.
We
going
want to
down
work out
there. The
this
frictional
force that's
Yeah.
opposing it.
Okay.
And it will always be a standard formula, which I'm going to come to that in the next
So the
few
angle they'll give you
examples.
the angle of the heel is 30 degrees.
That's
That'll
the
be
angle that
of
you
the-
would use.
Okay.
100%. Right? Yeah, that'll be okay.
Can you start again from F minus FU minus
Yeah.
MG? Yes.
Okay. So, remember, they asked. Huh?
Why you say, why you sorry, FU?
Right. So, remember,
Yes.
they asked you to calculate force.
Yes.
Now, our formula to work out force is,
Yes.
remember we said all this
Yeah.
here is used when you
Mm.
not working out force. Right. So the formula is the sum of the forces, which is equal to mass times acceleration.
Yes, I get it.
From this diagram, how many forces act on it? 3. Which is your applied force, frictional force, gravitational force.
Yes, I got it.
So, your applied force is moving in the positive direction. Because we chose that thing. So it's a positive F. Your frictional force is moving in the negative direction. So that's why we got minus. And gravity is also acting downwards, which is a negative force, which is minus. Good. Any questions? I don't know whether you're understanding it or what.
No, it seems easy.
Seems easy. It is. No, it is easy. Okay. Let's look at example
You're going to
3.4.
start reading yourselves. Yes.
We do this one in the test.
You're going to
Yeah,
substitute
yeah,
this
just
one
do
here.
it coming up.
Will you,
Take out relative velocity and put it right in.
will you actually test us on this one? I mean, like,
No.
I'll test you on how example 3.5 is. And maybe how 3.4 is. Okay. 3.4, they tell you that a car with a mass of 1000 kgs. So the mass of this car is equal to 1000 kgs. Is moving at 80 kilometers per hour on a horizontal plane and is braking. Let me draw the diagram, right? This is the car, right? This car weighs 1000 kgs. It's moving on a horizontal plane. Okay? Okay. It's moving at 80 kilometers per hour on a horizontal plane. So the initial velocity that they gave you is 80 kilometers per hour. Okay? And is braked to a state of rest. What does that mean?
Final velocity is 0.
Final velocity is 0. Okay. Over 45 meters, calculate the deceleration. Okay. So your displacement is equal to 45 meters. For the first one, they want you to work out deceleration. It's acceleration, right? But obviously, because it's slowing down, you would say deceleration. So, what's the first thing you do
Okay, see which formula you would use. So
before you get there?
Convert
Let's make all the same units, right?
Okay.
So you convert this 80 kilometers per hour to meters per second. So 1 kilometer is equal to 1000 meters. 1 hour is equal to 3600 seconds. So this here is equal to
2.2
2.222. May I explain that? Yes? Fine? Can I find? Yes, right.
Yeah.
Let's see which formula we can use to work out acceleration based on what we have. We know velocity.
You don't put your signs positive and negative.
Yeah, you know velocity.
Direction is so.
Direction, yeah.
Positive.
Okay, so this is positive, this is
Average or constant?
yeah. Okay.
Thanks, Joe.
Find velocity, we know.
Yes.
Yeah.
Initial,
Yes.
acceleration, we're trying to work out time here. Displacement, yes. Initial,
Yeah.
time, we're trying to work out. Acceleration, no, sorry. Acceleration, we're trying to work out time, we don't know, right? Yeah. Find velocity, initial,
Yes.
displacement.
Yes.
We can use that formula there. Okay? If I rewrite that formula to make A the subject of the formula, it's gonna look like. Everybody okay with it?
Oh, that's the other formula.
I just made A the subject of the formula, so I took U squared across and I divided by 2 times the displacement, which is this.
Yeah.
Okay, so this would be equal to 0 squared minus 2.222 squared all over 2 times, this is a S, huh?
Wait. Why you getting 2.2?
That's 22.
It's
now.
22, not 2.2.
Ah,
Yeah.
you're a legend.
And the 20 point recurring, I said.
You never said that. You said 2.222. There. And then distance is 45. So what you get?
That's 0.247. 0.247.
Yeah.
0.247.
Minus
Minus 0.247.
0 to
Minus 0.247.
Yeah.
Yeah.
How are you getting that?
No, that should be minus.
Yeah, it's what you gonna get?
Oh, it's squared. Oh, shit. I didn't put the square.
Minus 5.4.
I take it back.
Ah, sorry, man. I didn't put the square.
Wait, but hold on.
Sound to me?
It should be minus, isn't it?
Yes.
That's your deceleration.
Yeah.
Therefore, deceleration is equal to 5.487 meters per second squared.
5.48.
Okay, so the number does come out as a negative, but I'm saying that it's decelerating at that. Okay, can I take this up?
Yeah.
Yes. Okay. So, next question, they ask you to work out the braking force. So, because they said force, you're going to have to use F is equal to MA. Okay? Now, they're specifically just talking about the braking force. Now, the braking force in this instance will just be the mass times the deceleration. Because that's the force with which this object is being slowed down. When the object is being slowed down, it's being slowed down through your legs. Do you understand what I'm saying?
No.
Okay, so they ask you to, they want to work out the braking force. Your braking force in this instance here is going to be the mass times the deceleration.
Because it's no longer accelerating.
Because the deceleration is basically you braking. Okay? And how much are you stopping? 1,000 kgs. Okay? So the force will be equal
But
to
the braking force is the force that's going to be acting this way.
yeah. But they just specifically ask for braking force. They never ask for the total force being applied to the vehicle. They never ask for any of that, right? So it's just braking force. This will be equal to 1,000 times 5.487, which is 5487 newtons. You okay with this? Yeah. Good. How are we doing at 10? Please tell me I'm just a little bit before 2 o'clock. Okay, do the one more. Right. Yes, so far, please. Are we okay?
Maybe we get time to do homework.
At home.
Hey, don't tell me.
No, after Saturday, you can have a big bust up for the next couple of days. You don't have to do homework.
How's it back here?
Yeah, but he wants a homework completed by tomorrow. So tonight we have to do it.
I mean, you
Can't
can do
do
it.
homework.
It's no time
You can
to
do
do
it.
it.
We're too busy learning Pokemon.
And I don't care if you have to do this.
So wait, but let me see what's the story? Then I know maybe tomorrow I can just do the one more example.
So we give us value when we start this course.
So
Right.
I can standardize on
Okay,
makes it easier.
example 3.5. You see, but in this one, the only thing you need to know is to get that component. You know how I drew it over there and I showed you the force that will act down? It's always equal to mg sine angle. Right?
Oh, because it's
But
always
remember,
under.
the angle it's equal to the angle that they tell you. If they tell you the incline is at 30 degrees, but I'm saying mg sine of the angle, it's mg sine of the 30 degrees. So you don't need to do anything about 90 minus or 180
That one
plus
is
or anything like
cost
that. For?
in the textbook.
No, they over here they showed you how you break up the gravity into its two parts.
Oh.
But we only interested in the part that's going parallel to the slope. Okay. So they tell you that a mass of 20 kg accelerates uniformly from 2 meters per second to 10 meters per second in 50 seconds. That's the incline. That's what I want to say. Right? This is example 3.5. This is your incline. Right? This is your incline. You have a mass of 20 kgs. Okay? Okay? Which accelerates uniformly from 2 meters per second to 10 meters per second. So its initial velocity is equal to 2 meters per second. Final velocity is equal to 10 meters per second. The time taken for it to go from there to there is equal to 50 seconds. I know you only walk past the thing because you want to see yourself on YouTube. You're trying to get caught on the camera again. Right? In a straight line, up an incline, making an angle of 5 degrees. So if it's obviously this block is going to be moving up the hill.
5 degrees, 55. There.
Just a mistake. It was a typo. Right? The resistance against motion is 150 newtons. So the resistance is 150 newtons. Calculate the acceleration. Right? Now remember something on this block. Okay, it got a applied force. Like I said earlier, you are always going to have something called, guys, please pay attention to me. I'll give you a time taking. Okay? This block, you'll always have gravity acting on it. Right? Now gravity is gonna act straight down. Okay? What we need to do is break gravity up into its two components. So if you're looking at this would be like that, and this would be like that. It's two components. Right? It's vertical and horizontal component.
Okay.
Okay? See, you have to look at it like in terms of the slope. So you took your head a little bit.
You know, but I'm saying, would you even need the one actually?
You don't need that. I'm coming
Okay,
to that part.
okay.
Right? So the only thing, remember now, you can see which direction this is acting in. It's going to be opposing your force. Right? So this is the only force we need to work out. This here has nothing to do with anything. So I can just take out this line. Now, what is this line equal to? This line is just equal to mg sine of the angle. And what angle is that? It's this angle here. I can show you how this angle is equal to that, but I don't want to confuse you. Must I confuse you?
That confuses us. No, it's simple. It's opposite.
Yeah,
Work
so
out the triangle.
If you see this line was still here, right? And it's the same as me drawing my parallelogram. Okay? Okay. So this 5 and 90 degrees here, what's this angle?
85. 5 and 9.
85, right?
Yeah, 85.
85. Remember, this is 90 degrees. What's this angle? 5. Opposite of it over your hypotenuse is sine. So this line is parallel to that, it's going to give you that value. Okay? But you don't need to know that. Main thing I need you to know, guys, please, is that this component is equal to mg sine. Okay, they'll never ask you explain to me how it's equal to mg sine. It's just that. Cool. We know all the forces that act on it. We're fine. Right. Let's work out acceleration. Okay? Okay, first thing to get into the habit of, once you come to this part where you get mg, work it out, right? Because we have everything. We know that this block is 20, we know that gravity is 9.81. So this would be 180, 90,
96.2.
196.2 newtons. Right? Cool.
Yeah,
Figure it out just now. Right? Here. Okay. Acceleration. Okay. We can use one of these formulas.
So if you use the mg cos of 85,
Yeah, you give us a
same answer.
But simple thing, because you just remember, that part of the mg sine of the angle. The angle that they give you for the incline, you just say mg sine of the angle. And remember, we'll be given the mass of the block. We know gravity. They're going to give you this incline. So you just substitute it, you already got that force.
So if you look at it right together, maybe I'm going off. Since this is 5 degrees, right? Right, that'll be 5 degrees, right? That'll be 85. Right, so you're working out this one here, so obviously cos of that angle will.
What the same?
No, I just drew a parallel. It's the same angles. That's good.
Yeah.
Yeah.
Yeah, that's alright.
Yeah.
Okay, later.
Later, eh?
Take this one out.
We'll come with it.
Take it out.
Relax. It's not bad. It's not bad, right?
Yeah.
Your gravitational force is this.
Yes.
Finished, right? Mg sine of the angle is given to you, it's your incline. Other force acting away is your frictional force. Your force being applied is that. Finished. They give you initial velocity, final velocity, time. They asked you for acceleration. Okay? So acceleration is not one of the forces question. Nothing, we don't have to use forces to work it out. So what formulas we can use? We can use those formulas. Do we know the final velocity?
Yep.
Do we know initial?
Yes.
Do we know time?
Yep.
So let's just use that formula there. If I had to rewrite this formula, I can say A is equal to V minus U all over T.
Yeah.
Okay? This would be equal to 10 minus 2 all over 50, which is
50 minus 8 equals 50.
0.1.
6 meters per second.
Oh, it's done more. Meters per second squared. That's it. Right? Acceleration done. Okay? Then they ask you to work out the magnitude of the force that causes the acceleration, which is your applied force. So, because they said force, we'll have to use the sum of the forces equal to mass times acceleration. How many forces act on this?
3.
3. What are the 3?
Frictional
Gravitational,
and
applied force. So, your applied force is what?
What we're looking for.
It's a positive, right? Okay, so this is F minus your frictional force and your gravitational force. Why? It's acting away from motion. So, your frictional force minus mg sine of the angle. Okay, equal to mass times acceleration. Is that difficult? No. Everything is the exact same like how we did the other examples. Same thing, right? So, we want to work out this. We know this value here is 150 minus
7.
mg is 196.2 sine of 5 equal to
17 point.
okay, let me 20 times the acceleration, you worked it out here, which is 0.16. Okay, cool. That was just simple substitution. If you put that whole thing in your calculator, what do you end up with? Remember, you multiply this out, and then when you take this over, you'll add it to that. Will you believe me if I tell you this is like one of the hardest ways they can ask you?
Well, that's it. This is the hardest
They
situation.
test a bit more on the work done and the power which you're going to do tomorrow, and they test a lot in dynamics on the, and they got potential energy and kinetic energy, right? Because that's some similar to what they could test you on with the pulley thing,
And this one.
and then an incline question, I guess.
But the power is, we've already done the power, just using the, it's more stuff to power.
A little bit more, but it's the same principle. You know, like force times this, blah blah blah.
Yeah.
155.956. 150.956.
170.3.
170 by 3.
What I did wrong here?
I don't know.
So we'll just use mg sine.
Always,
Always.
always. Remember, if this block was moving downwards, right? This here is moving up the incline. If it was moving down, you would have said F, because F would have been moving this way, plus mg sine of the angle, minus frictional forces. Okay? What about you know on page 64 and 65, right? The summary of the module.
Yeah.
See on page 64, they give you Newton's laws, they give you an explanation. On the next page at 65, they tell you movement up and incline. They give you a standardized formulas for whatever you'll be dealing with. So whenever you got something moving up an incline, you're always going to end up with F minus frictional force minus gravitational force. And the gravitational force to work it out is mg sine of the angle.
Okay.
And then when they tell you when it's moving down the incline, you see the only thing that changes is you add the gravitational force. Guys, is anything we did here difficult?
We have it's moving down, moving up you.
You minus. Because it's reacting away from us. Nothing. You can picture this in your head exactly like how you would see it. Right? Another, just one more thing before I finish. Okay, your homework was activity 3.1, and it was question 1, question 2, question 5, right?
When we need this is you next week.
No, I'll probably give you some time to do it. Oh no, I'll probably, yeah, Wednesday if we need to, right? Because then I'll do work done and power, I'll give you a little bit more homework and then we'll mark everything on it. Okay? So tomorrow we'll do work done and power. Just for question 5, because then I know you're going to message me or ask me, I'm going to tell you now, right? So, see how they tell you for question 5, a car with a mass of 900 kg accelerates uniformly from rest up an incline of 1 is to 40. 1 is to 40, right? What do they mean by that? See if this is your incline, right? They gave you a ratio. All the ratio is basically telling you, it's giving you the first number in the ratio is your opposite value, the second number is your hypotenuse. So 1 is to 40, right? Opposite, hypotenuse. If you have to draw this as a 90-degree triangle, this is your opposite, if this is your angle, right? That's your hypotenuse, opposite, that's your hypotenuse,
So you need to work it out.
right? So this here is 1, this here is 40. How would you get that angle?
Sorry.
Sine. For what would you do to sine?
Huh?
What would you do to the sine?
Sure, it was
Right? Inverse sine 1 over 40.
Yeah.
That will give you your angle. That's the angle that you would use. That's it. Okay? You'll even see in past year papers when you'll do it, they never just tell you at forms at an incline of 60 degrees, 40 degrees.
Do we have to show that calculation?
Nah, not really.
Not to show.
Yeah. You just need all its angle is equal to shift
I
sine.
know, I thought maybe the reason I asked you for it is that you need to show it.
They just want to do something to throw you off. That's what they do.
So they can ask that in any question, not only this, you can guys can ask us if for relative velocity or whatever. They use the same thing.
Yeah, it will be the same thing. But in our relative velocity question, we don't really get inclines like that. Or situations where you, if we do get it, that 1 and 40 is the giving you a vertical or horizontal component or something like that.
Yeah.
Right?
Sun is
Okay, guys, are we good?
Yes.
Yeah.
Dynamics is not so bad. We all still love engineering science. Yes. Okay. Yeah, we'll stop here for today.
Did we start recording yet?
Oh, I didn't give her the register. And nobody even reminded me.
I think yesterday's one, because I watched the video.
Did you? The whole thing from start to end.
Even your conversation, you see the guy walking fast.